In this video, we want to learn some properties of determinants. The first property is that if we have a square matrix A and we multiply it by a constant like k, determinant of this new matrix is equal to k to the power of n times by determinant of the original matrix. For example, if we have a square matrix, note that here n is the number of rows or the number of columns of the matrix A. Because the A is a square matrix, so the number of columns is the same as the number of rows. For example, if A is a 3 by 3 matrix and we multiply it by a constant like 2, determinant of 2A is 2 to the power of 3 because the matrix A is 3 by 3. So determinant of 2A equals 2 to the 3 determinant of A. If the matrix B is 2 by 2 and we multiply by say 5, determinant of 5B equals to 5 to the power of 2 determinant of the matrix B. Now let me show you an example how we can use this property for answering questions. Suppose we have a matrix A in the form of 2, negative 3, 1, 5, and the matrix B is equal to 3, 1, 2, 4. Then we are asked to find determinant of 3AB. From this property that we learned here, first we can write this in the form of 3 to the power of 2 determinant of A. We can bring this constant and write it as 3 to the power of 2. Why the power is 2 here? Because the matrix A and B are 2 by 2. So when we bring this constant from the determinant, we have to raise it to the power of n, which n is the number of rows or columns. And because these matrices are 2 by 2, so we raise 3 to the power of 2. Now maybe you think first you have to multiply A by B. Yes, you can do this. Multiply A by B and then find the determinant of the new matrix. But it's a bit hard to multiply this matrix by this matrix. There is easier way to find the determinant of A times B. If you remember from the previous video, we learned that determinant of A times B, this is one of the properties of matrices, multiplication of matrices. Determinant of AB equals to determinant of A times by determinant of B. It's easier to use this property for finding the determinant of AB. So, instead of multiplying A by B, you can say this equals to 3 to the 2, which is 9, times by determinant of AB based on this property is equal to determinant of A times by determinant of B. Determinant of the matrix A is 2 times 5, which is 10, minus negative 3 times 1. 10 minus negative 3 is 13, so this equals 9 times 13 times by determinant of the matrix B is 12 minus 2, 10. Now 9 times 13 is 117. 117 times 10 is 1170. Let me show you another example. Suppose matrix A is negative 1, 2, 5, 0, 1, 2, 0, 0, 3. And matrix B is 2, 1, 7, 0, 2, 1, 0, 0, negative 1. And we are asked to find determinant of negative 3a b a transpose. From the above property, we learned that we can bring this out from the determinant. Because these two matrices are 3 by 3, so when we bring negative 3 out from the determinant, we have to raise it to the power of 3. So, the first thing that we do here, we write this as negative 3 to the power of 3, determinant of a b a transpose. Now for finding determinant of a times b times a transpose, again we use this property. Whenever we multiply two matrices by each other, determinant of a times b equals determinant of the first matrix times determinant of the other matrix. If we use this property here, we can write this as negative 3 to the 3 is negative 27. Determinant of a b a transpose is determinant of a times by determinant of b times by determinant of a transpose. This is much easier to use this property than multiplying these matrices by each other. If we want to multiply matrix A by B, because these are 3 by 3 matrices, it needs lots of calculations. Now, we have to find determinant of A, determinant of B, and determinant of A transpose. What is the determinant of this matrix? Note that this matrix here, its matrix A, is upper triangular. If you are not familiar with triangular matrices, you can watch my videos about triangular matrices and other type of matrices. This is upper triangular matrices because all the terms below the diagonal, this is the diagonal of this matrix, all the terms below the diagonal are 0, so this is upper triangular matrix. And when we have upper triangular matrix, determinant is the product of the elements of the diagonal. We know this from the previous video. So determinant of the matrix A is equal to, let's write negative 27 again. Determinant of the matrix A is negative 1 times 1 times 3. Negative 1 times 1 is negative 1 times 3 is negative 3. So determinant of the matrix A is negative 3. Determinant of the matrix B similarly is 2 times negative 1, negative 4. Again, why we can find the determinant of the matrix B in this way? Because this matrix is upper triangular. But how we can find the determinant of the matrix A transpose? Again, from the previous video, if you remember, determinant of the transpose of a matrix is equal to determinant of that matrix. There is no difference between determinant of transpose of a matrix and determinant of the original matrix. So, because determinant of the matrix A is negative 3, so determinant of A transpose is also negative 3. Now, if we multiply these numbers by each other, note that we have 4 negative, so it becomes positive number. 27 times 3 is 81. 81 times 4 is 324. And 324 times 3 is 972. If we have a matrix A and we raise it to a power, say n, note that n is an integer number, 2, 3, any positive integer. Determinant of the A to the power of n equals to determinant of the matrix A to the power of n. So you can bring n out of the determinant and put it above the determinant. If you don't know what is a to the n, for example, if you have a to the 3, a to the 3 means that multiply a by itself 3 times. So the power of a matrix means to multiply by itself, like the normal power for a number. This property is also one of the useful properties of determinants because it simplifies answering questions like this. We are given this matrix A equals negative 2, 3, 1, 5. And we are asked to find determinant of a to the power of, for example, say 3. One way to find this is to multiply this matrix by itself 3 times and then find the determinant of that. But multiplying a matrix by itself and multiplying matrices, as you know, is a bit hard and needs some calculations. It's possible to make mistakes during those calculations. So it's better to use this relation that we learned here. We know that if we want to find determinant of a to the 3, we can say this is equal to determinant of a, then raise it to the 3. What is the determinant of this matrix? Negative 2 times 5 is negative 10. Negative 10 minus 3 is negative 13. So now we have to raise negative 13 to the power of 3. Because the power is negative, because the power is odd, the power is 3, negative remains. Now we have to multiply 13 by itself. So 13 times 13, 3 times 13 is 2197. Let me show you one more example. The matrix A is negative 1, 2, 3, 1. Matrix B is 2, 4, 1, 1. And we want to find determinant of 3ab squared. First, note that we can bring 3 out from the determinant and raise it to the power of 2. Why to the power of 2? Because these matrices are 2 by 2. Then we have determinant of AB squared. Now, note that 3 to the 2 is 9, and determinant of A times B squared is determinant of A times determinant of B squared. When we have the product of two matrices, determinant of the product equals determinant of the first one times determinant of the other one. Determinant of the matrix A is negative 1 times 1 is negative 1. 2 times 3 is 6. Negative 1 minus 2 times 3 is minus 7. So determinant of the matrix A is negative 7. If you don't know how to find the determinant of matrices 2 by 2, 3 by 3, watch my video about determinant of matrices, finding determinant of matrices. Determinant of B squared is determinant of B squared. As we learned here, we can use this property. So determinant of B squared is determinant of B to the power of 2. What is the determinant of this matrix? 2 times 1, 2, minus 4, negative 2. Now if we raise negative 2 to the power of 2 equals 4. So times by 4. 9 times negative 7 is negative 63. Negative 63 times 4 is negative 252. Let me show you one more property of determinant of matrices and then I finish this video. Suppose we have m by n matrix A. So note that matrix A is not a square matrix. And we have another matrix, say B, which is n by m. So none of these matrices are a square. But if you attention, A times B is a square matrix. Because when we multiply A by B, the result is a matrix, is a new matrix, which is m by m. Why? Because the first matrix is m, has m rows, so the result of multiplying A by B has m rows, and the matrix B has m columns, so the product of them has m columns. So when we multiply A by B, we get m by m matrix. This is a square matrix. Now note that if, it is important, if M be greater than N, then determinant of this new matrix, determinant of A times B, determinant of A times B is 0. You don't need to calculate determinant of A times B. It's always 0. This is one of the properties of the determinant of matrices. For example, suppose you have matrix A, which is, say, 4 by 3. And the matrix B is 3 by 4. So that A, the size of rows of A, the first one, is greater than the number of columns. It's important that M should be greater than N. If we multiply A by B, the result is a 4 by 4 matrix. Determinant of this matrix is 0. You don't need to calculate. And it doesn't matter what is matrix A, what is matrix B. Always the determinant of A times B is 0. But note that determinant of B times A is not necessarily 0, because B times A is 3 by 3. Determinant of the bigger matrix is 0, because A times B is 4 by 4, but B times A is 3 by 3. So only A times B, determinant of A times B is 0, not B times A. I hope by watching this video you have learned about some properties of determinant of matrices. If you like this video, please subscribe in my channel, and thank you for watching.